Okay, so let's move on to our last topic for today, iteration. So when I was a kid, I had a little like toy laptop computer, like a VTech toy laptop, and it actually had a programming language on it. You could program in BASIC, or if you've had a TI-83 calculator, you could program in BASIC. It's a very simple programming language. And the first program I ever wrote was launching a rocket. Like I'm at NASA and I want to launch a rocket. T minus, plug in a number and then launch it in that many seconds. So here's the code you could write to do that. So I want to launch a rocket in 10 seconds, so I will print launching in. I'll print T minus 10, and then I have this function here called time.sleep. Time.sleep literally just pauses for 1 second if I do sleep 1, and then print again T minus 9, T minus 8, all the way down to blast off. Okay, and so I run this I run this code. You see it'll pause between each, and then eventually the rocket will launch. Awesome, right? Now, this bit of code, of course, it was very awkward to write. I'm repeating a lot. Of course, there's a better way to do this. The better way is to use a for loop. Okay, so the way I do this is I take all the code that I was repeating and say, okay, let's repeat this many times, or with these parameters, these values. So here's the syntax, or here's the bit of code that would do the exact same thing on the previous slide, but with much less typing. So I will first print launching in, and then I will say, okay, for t in this list of values, print that time t, and then sleep for a second. What it'll do is it'll start by setting t equal to 10, and then it'll print with t equal to 10, t minus 10, sleep for a second. Then it'll set t equal to 9 and do the same thing, print t minus 9. And it'll do this all the way down to 1. And then I will print blast off after all of this is done. So it'll do the exact same thing with much less typing. Cool, blast off. All right, so here's the syntax of a for loop. Okay, so I write for. I write a loop variable. This can be any name. It's what you're going to assign the values in the sequence, 10, 9, 8, and so forth. So you write it for loop variable in sequence. The sequence could be a list. It could be a variable containing a list. It could be an array, anything that's called iterable in Python. But in this class, we'll mostly focus on arrays and lists. And then you give it some code that you want it to execute on every iteration. Okay, so for every value in the sequence, it'll execute the body using the current, or with the current value set to be the value of the loop variable. So as with other things in Python, like defining functions and conditionals, the indentation matters. So the body has to be indented by a tab. So the loop variable can be anything. Like I said before, I could define it to be x, I could define it to be t, I could define it to be my favorite variable, whatever you want, as long as it's a valid name. So I'll write for x in this list of numbers, then I will print x squared. So I'll get 1 squared, 2 squared, 3 squared, and 4 squared. Okay. Now, it's kind of tedious to write out a list 10, 9, 8, 7 all the way down to 1, but we already know how to create such a list or how to create such an array. We use arange. So I've imported NumPy. I'll write NumPy or np.arange. I'll create an array starting from 0, going up to, but not including 10. Remember, it excludes this. So I'll get 0, 1, 2, all the way up to 9. And I will write a for loop. I'll iterate over this array, and I'll print out each entry in the array. Kind of boring. I could also do this. I could square everything or whatever. I could count down just like I was doing in my NASA rocket launch example. So for x in the array, I will make an array that starts at 10, counts down, but excludes 0 in steps of -1. So this goes 10, 9, and so forth, down to 1. If I zoom out here, you'll be able to see that the end value here is 1, not 0, because it excludes the last thing. Okay, so if I have an array or a list that contains strings like this, there's a couple ways I can iterate over this. So I could do this. So let's copy this code. Okay, so I have my list of flavors. So I could write something like this: for flavor in flavors, print flavor. And it'll literally just print out all of the strings in that array. Sometimes, though, you want to also have the number. So I want, this is 0, chocolate is entry 0, vanilla is entry 1, strawberry is entry 2. Okay, and so there's a couple ways I can do this. So another way of iterating over this list is I create a range, so an array with entries 0, 1, 2, and then I ask for each of the entries in the array. So I get flavors entry 0, flavors entry 1, flavors entry 2. So if I do this, I'll get the exact same information, just with more typing, basically. Here's a trick, though. If you want to get both pieces of information at the same time, you can use this Python function called enumerate. So what this does, I'll write this code out here. Whenever I enumerate a list or an array like this, it'll give me back two pieces of information on every iteration. It'll give me the index, the integer position that I'm currently at, and it'll also give me the value. So in this case, the flavor. And they'll be paired. So I'll get back on the first iteration here, 0 chocolate. On the second, I'll get 1 vanilla, and so forth. So that's a handy function to know. Okay, so something that we're going to be doing in this class is building an array by iterating. Okay, so how many letters are in each name in this list, for example? So I want to create a new list or a new array with the number of letters in Winona, the number in Xanthippe, in Yvonne, and Zelda. Okay, so here's the general strategy that we work with. First, going to start with an empty array. The way I create that is with lengths equals numpy array, give it an empty list. Okay, and then I say for name and names, I'm going to make a for loop that analyzes each piece of this list on each iteration. Okay, so I will calculate the length of a name, the current name. Let's get rid of this code. Okay, so I'll calculate the length of the current name with len. Okay, so let's print this out and we'll see what we get. Okay, so it says Winona is 6 letters, Xanthippe is 9, and so forth. I want to save these results into a list or into an array. I've created an empty array here, so what I'll do is on every iteration, I will append the current result to the end of this array. And so the way that we do this is with the function np.append. The first argument is the array that you want to append to, so lengths. The second argument is the value that you want to append. In this case, I want to append the length of the current name. This will operate in place, so it doesn't return anything. It just automatically updates lengths. So I'll do this, or sorry, got that backwards. It does create a new list, or new array, so it doesn't operate in place. So you see what happened there is I ran this code, okay, I'm appending the value to the array, but whenever I print out the array at the end, it's still empty. Okay, that's because it's just creating a new array here and not updating. So in order to update, I can overwrite, okay, like this. I assign the result to the name length. Now when I run this, I get an array with the results contained within it. Okay, this is something we're going to be using a lot of. We're going to be running experiments with for loops, big for loops that are running for many iterations, and on every iteration we want to save the result back into an array. And so we're going to see a lot of numpy.append here in the future.